This is Daniel McNerney's video submission for Space Invaders Milestone 1. Let's open up the project and see what it looks like. Go ahead and running the project. You can see that we have 3 different types of aliens. Each one is switching between 2 different sprites in order to animate. They're moving as a grid. They move until they hit the borders of the screen, and then they change their direction, skip their horizontal step, move down 1 step, and then change direction and begin moving horizontally in the other direction. This is all just hard-coded. It's not hitting any collisions. It's just hard-coded to this particular window frame, and they're going to continue animating off the edge. So let's see some of the code that's running this. In our game, we see initialize, nothing unexpected, low content. We're initializing all of our managers. My timer manager, I was trying to figure out a good way to get the current time into there, so I just sent it an update before it has any nodes attached to it, so it can get its own internals updated. Here we are creating and loading the textures. We have a couple of debug textures, and then the sprite sheet that we're going to be working off of. Similarly with the image, a couple of debug images, and then here's what we're really using: our Squid 1, Squid 2, Crab 1, Crab 2, Octo 1, Octo 2. Then our sprite goes ahead and takes our, happily named Test Happy Alien, image name Crab, and goes ahead and creates 3 sprites, 1 for each of the starting alien states. And our timer manager creates a new timer event and adds itself onto the priority queue. Our factory is created. It comes along, or we create a PCS tree so we can hang our objects onto that tree as they are created. The factory is specific to whatever sprite batch bucket that you want to put objects into, although multiple sprite batches are enabled. In this example, all of them are sitting onto just the 1 bucket. And when it goes ahead and it creates an object, it uses the case to figure out what type of object to create. It adds the object to the game manager so we can iterate through it later. It adds it to the PCS tree so we can access it through the tree recursively, and it attaches it to the sprite batch manager so we can draw it later. And here we have an example where we create all of our game objects. Update is nice and simple. Timer manager update searches its priority queue for any events to fire off and does so. And game object manager update searches through every single game object and runs their update, whether it does anything or not. And here we have an old prototype, how we were running our updates. Draw is just run with a single line sprite manager.draw, and the sprite manager iterates through all of its buckets. Here's our buckets, and iterates through every link in that bucket and renders every object that it finds within. And here's an example of our old render system. So let's take a look at some of the design patterns involved here. In our image, texture, and sprites, we have kind of our classical singleton pattern with a singleton manager, which is attached to a doubly linked list through their abstract classes, which reaches over to their data classes. And we can also see how these are wrapped to push the Azul aspects out as much as possible. Inside of our game object diagram, we have another singleton manager. In this case, it creates game object nodes, which connect over to game objects. And game objects are going to show you an example of the proxy pattern. Game objects are pushing their values over to the proxy sprite, which when update is called onto the proxy sprite, pushes its values onto the sprite and runs that update. And our game objects can be of any different class that derives from it. Our alien factory is used to create game objects. It's creating multiple game objects, and it's attaching them to the necessary data structures we're going to use to find them later: the PCS tree, the game object manager, and the sprite batch manager. And our timer diagram is going to show us some of our command pattern, and it's organized in a priority queue, and that's what, based on the trigger time. And we also allow the timer events to have a delta time, so they can tell us how long till they fire off. And once they fire off, it goes ahead and activates the command, and the timer event has no idea what the command actually does. It just command executes, and whatever that class happened to be attached to is what's going to execute. In this case, our timer commands are re-adding themselves to the priority queue. Okay, so that is my an overview of my Milestone 1. I think I do have to mention that the PCS tree, I am adding items to the PCS tree, but I was having trouble recursively taking items off of the PCS tree, specifically relating to the null object. I was having a lot of trouble figuring out how to handle updates on the null object and references on the null object, and dereferencing that null object without having to create another, like a Zool sprite that connects to it. So right now the timer manager is just hard-coded using some of the test code that I implemented very early on. Okay, so that's just about everything I had to show you. I ran about a minute long, so I'm sorry about that. Thank you for your time.